So 1, 2 in Intro to Probability and Stats. We're just going to display categorical data today. That's all we're dealing with. No quantitative data, just categorical data. And there's 2 different charts to put them in. We saw them on our activity today. The bar charts, which is shows the category as a bar, hence the name, and the heights of the bars. They show the different category frequencies, or sometimes they use the relative frequencies. Like in our activity, we did it about the social media apps. Sometimes the category frequencies was like how many times people said Snapchat, how many times people said Instagram. And if we wanted to do it with the relative frequencies, we would have done it with the percents instead. So a bar chart, you've seen many of those in your math life. And then the pie chart, sometimes also called a circle graph. You know, it's like all means the same thing. It is shows each one's, they use the frequencies or the relative frequencies again. But it's only categorical. Next time we'll talk about quantitative data. Today is categorical data in this puppy. And then what we'll do on this very first problem is we'll have our computers ready to go into an applet and put this information here. They surveyed 40 students, so that's handy that sometimes they tell you how many total were there. If they'd rather be famous, happy, healthy, or rich. Use the applet to make a bar chart of that data below. So for those who are unfamiliar of how to get there again, it is on back to the Canvas agenda and click Applets. Let's say you still had the old one open because this is the one we did on our activity. If you wanted to change all the data and you had it open, scroll down to the bottom and then you just hit like back to menu and it'll take you right back to where we were at. But if you could get to the applets, we will again do one categorical variable, single group. We'll explain how the other applets work when we get to them. But this is about like just what they surveyed these students to be about. So it's like, what would you rather? I'll let you guys type with me. What would you rather have? What would you rather have? And if we're kind of going back and forth here between all these, you see they surveyed all these people. They said, hey, would you be famous? Would you rather be healthy? Or would you rather be rich? Categories that we'll just kind of type in. So if we go back to the applet right here, one of them was famous. And they had a frequency of 7. Another one is happy. And that was 21. I need to add more, so I have to hit this plus again. So healthy. 4 people said that, and rich. I like that they told me that the total had to be 40, so it kind of helps me double check when I begin analysis if I made a typo or not when I punch these in, because that is very normal to hit the wrong button. But if I begin the analysis, if I look down here, it tells me way down at the bottom that I did have my total 40, right? So that's good. But they say make a bar chart of this guy right here just to do it. The only reason I had you type that in is just so you could practice that one more time of how to put that data in, right? So we have done that, and there it is on my screen right there. Let's see if we can just like fill out this sentence that they have most of it filled out for us, and we just got to fill in the blanks. It says more than half the students, blank, said they would rather be blank. So if we kind of look at the chart right here, which one out of all with category 1, they said they'd rather be happy, right? So that goes right here. They said they'd rather be happy. And they just wanted to know like the frequency of it. So if you look, you can see it 2 different places. They have the chart to see it, but sometimes they don't have that, and you have to read the bar chart itself. So it's like where you would trace this guy over, and you see he's between 20 and 22, so that would have to be like at 21, but doesn't it totally tell us that there also? So 21 said they would rather be happy. Similar number of students chose blank, but you see how it has 7 after the fact of it? So which one would go there if 7 people said that? Which one? Famous. Or blank, rich. The least popular was healthy, because only 8 of the 40 students chose that. And I always like to kind of take this and take it to the next level. These were students that they surveyed. Which one was popular? Healthy. If you asked like people healthy, happy are probably the two that are the most popular, right? You know, it's like the older you get, the more you care about your health. Cool? So that's all we need our computer for right now on this. You can kind of close it down if you wanted to, especially if you're low on some power and everything like that. So we can finish the worksheet, I think, without it. But the next one, they gave us the bar chart already. It's a bike shop. It rents road, mountain, hybrid, cruiser bikes to its customers. In order to study the distribution of bikes rented, the bike manager took a random sample of bike rentals and came up with the following graph. So they're selling bicycles, and they have different categories of bikes, right? Are we cool with that? That's why a bar chart was used for all the categories. It says fill out the frequency and relative frequency. There's two ways you could do that. You can use the app and put all the numbers in, it'll do the calculations for you. But sometimes that's a lot of work, you know, to go to the website, punch all that in. Maybe by hand would be easier, so I'll let you decide. Road bike. How many road bikes were on the chart? 15. So I like to put that at the top of there also. 15. Mountain bikes. Part road bike, part like mountain bike. Tires for the surfaces that you drive on. Go into the applet for it to add those up for me. Dude, it's only like 4 numbers. I think I can add them up. And sorry, I forgot to tell you to grab a calculator, so I'll just kind of show you what all the calculations are. If you add all those bad boys up, which I know we know how to do, how do you feel about getting 37 of those puppies? Cool. And for the relative frequency, notice this. This is something you'll have to do when you start doing homework. Make sure you read how they want the answer, right? So they say the relative frequencies to 3 decimal places. The way we did that last time is there are 15 road bikes out of 37. So if I do 15 divided by 37, I need to round that to 3 decimal places. So if I want to round it to 3 decimal places, I look to the decimal place to see if this 3rd decimal place needs to stay the same or round up. This is a 4, which is not 5 or bigger. So what do you want to do with this guy right here? Leave him or round him up? Leave him. So we'll put 0.405. They don't even want it to be a percent. Otherwise, they would have told us. But that would have to be, they say 3 decimal places, so we're leaving him a decimal, 0.405. For a mountain bike, that would be 7 out of 37. So let's round that to 3 decimal places. We're going to look to the 4th spot right here. 6. Are you with me on that? So 0.189. Cool. If you need help rounding later, I will help you. And then hybrid, 6 out of 9. Excuse me, 6 out of 37. So point what? Keep that 2 the same or round him up. Keep him the same, 0.162. And then the last one, 9 out of 37. 9 divided by 37. 0.23, excuse me, 0.243. 0.243. Are you cool with how I got those numbers? Again, if you have the applets open and you wanted to punch all that in and let it do the calculations for you, it'll do that, right? You know, either which way. Down here, sorry the little check boxes didn't show up on your printout, you know, but I have them up here and then they didn't print off. It says, would it be appropriate to make a pie chart with this data? Well, I didn't tell you when it is appropriate. You have to have 100% of the data to make a pie chart. You know, like the entire circle graph adds up to 100. So if you add up all these relative frequencies right here, if you add them all up, those would add up to the number 1, which as a percent is 100%. Like, isn't this the every bike that they're selling at this place? That is 100% of their data. So anytime you have 100% of the data, it is okay if you want to like make a pie chart out of that. But if you don't have all the data, you can't make a pie chart. It's like, well, we're missing some stuff, so I can't make a pie chart out of it. Are we cool with that? All right, speaking of which, let's go look at a pie chart. I'm very sorry that your worksheet is like upside down and flipped. There was a mistake at the copy machine when that happened, so you'll have to rotate it around. And black and white, not the easiest to see on paper. I have it on color here on the screen, but a pie chart shows a couple these expenditures. That's like how much money they were spending, you know, expenditures in the last quarter. Check out that pie chart and talk with your category. The most expenditures out of all those categories. Which one do you guys think? Technology. You can see it a couple of ways on a pie chart. It's the biggest piece of pie, right? And it's got the largest percent on it. If a company had $65,000 in expenditures last quarter, how much was used for travel? So if I go to travel on the chart, you see this 30% of the pie, right? So what I have to do is take that 30% as a decimal, which is 0.30, and take him times our total amount of 65,000. And again, I'm sorry, I forgot to let you have a calculator. So if I do 30% times 65,000, this is how much money they spent on travel, $19,500. Did that make sense? Where I got that number from? The percentages for the piece of pie times the total, $19,500. And if you do notice, all of these percents do add up to 100%. Yeah. Cool. There'll be some other questions about pie charts on your homework, but I'm not trying to bore you with them. I think it's easy to start. If you have questions, I will help you with them. But there's one other concept for the day, and I'll tell you what, it is the most realistic for us right now, especially if you scroll on the phone on social media to see bad information presented to us. There's some stuff about bad graphs, right? And some people are evil, and they use bad graphs on purpose to try to sway you to think a different way about some stuff. All right? There are different ways that some sort of writers, be it politicians or other kind of people that are trying to influence you, use bad graphs to mislead you. So on your chart right here on paper, we'll put these 5 things as they come across in this little box right here that says 5 different ways. So here's way number 1. Some of these are weird, and we'll kind of feel free to ask questions, but here's way number 1. Let's just put in there called omitting the baseline. If you put that for reason number 1, and I'll explain it after we write it. Omitting the baseline. So if I was to just snip this guy out on the left right here, I didn't want to do that. If I was to just snip this guy out on the left right here in a new page and make him larger for you to see, this is a bad graph. Because here's what it looks like to the average person. Which group, regardless of us even knowing what the concept of this graph was about, looks like they did the best? Which group? And they made the bar so much higher than all of the other bars because baseline. What does that mean? The baseline is like down here, the bottom of the graph. And what number did they start with? 50. Where is the graph supposed to start at? 0. Are you with me on that? That's a bad graph because they omitted the baseline. This is the same information right here, but you see if they put it down at 0, the bar for group A is not nearly as significantly higher than the ones for group B and C. Yes, A is still better, right? But it's like the distance that they traveled above it looks so much more normal because they actually have all of the data represented and they didn't cut the bottom off, right? Omitting the baseline. They try to make it look like A was so much better than everybody else. So that's one way they do it. A second way is by manipulating the y. And here's what that means is, like, if you look at this guy on the left, the blue dude right here, the highest it ever gets is about like right here, which is roughly 15-ish or so, you know, maybe 14, maybe 13 on the y-axis. And they left all of this space up here when there's no need for that space. If there's going to be nothing on a graph, it shouldn't be a part of it. What they did instead, the proper way, is to just space it out to where the y-axis goes up as high as you need it to go, and then you can see the peaks and valleys of this graph look a whole lot more accurate because you don't have a lot of wasted space up here. So manipulate the y they can make a graph be bad. The third way is cherry picking the data. Cherry picking the data. Cherry picking the data. And if you know anything about basketball, like cherry picking is when one person like doesn't run all the way down to the other end of the court to play defense. They just hang out by their basket and wait for a rebound, and somebody throws it down and they get on the basket real quick. So cherry picking the data is fancy for picking what they only want to show you. This purple graph went from May 2020 to August of 2020, which would be basically this little zone in the full scope of things. Here is data all the way from 2019 to 2023. This is what the data looks like, but they just cherry picked this little bit out to show people because it's in that era. But can you kind of see, if you look at the whole study, some stuff went bad, some stuff went real bad, and then it started being okay. You know, it's like they said, no, we're only going to show you the good bit, right? We're going to cherry pick the data out and show you this and go, look how great we are. It's like, show me a big picture, please. You know, it's like, it's not very good data. Fourth way, using the wrong graph. They just totally used the wrong graph to get some data. Totally wrong graph. Pie chart, horrible graph to use on this one. Why? Because Team B has 64%. I have no idea. I'm just going to make some up. Let's pretend they're a basketball team, and that's their free throw percentage. Like Team B might be shooting 64% for their free throws. Team A, 50%. And Team C, 38%. Why is a circle graph a horrible graph to use in that situation? 64, 50, 38. Way more than 100. It's more than 100%. It just looks stupid. It's like, wait a minute, how can this be 64% and this be 50%? Isn't 50% supposed to be like half the circle? You know, it's just bad. It's like, oh, no, it's just their free throw percentage. It's like this bar graph would make like so much better for the brain. It's like, okay, now I can see what the free throw percentages are. And the last way is going against conventions. Going against conventions. It means like you're doing something not normal. You're going against the grain, going against conventions. Here's what they were trying to do. They were trying to check the population density. And can you see this scale right here? It's bad. The denser something is, you'd use a dark color right here, and it's like they went from dark to light to say, hey, the lighter it is, the more people live there. Like, that's not right. It should be the other way around, you know, like this way right here. So that's kind of the idea. Let's try a few that we have right here and see what you think. There's 5 ways right there. Here is a graph. It's on your paper as well. What a weird looking graph. It's like, hey, these are the gun deaths in Florida from the 90s to 2010s. Let's look at the first one and see what's going on. Did they omit the baseline? Like if you look down at the bottom, it's supposed to be 0, and that's 1,000. But we got to kind of add a caveat. You see on the y-axis there is a 0, but he's kind of in the wrong place. You know what I'm trying to say? It's like it's at the top of the graph instead of the bottom of the graph. So to me, that automatically goes into step 5. It's like they went backwards to what they were supposed to. It's like they had the 0 on the top when it should be on the bottom, right? They didn't manipulate it in any way. It's still counting good, you know, but it's like, yeah, they went against convention. So if you would put on this number 5 on your worksheet, like instead of writing it all out, it's just reason 5, going against conventions. Does that kind of make sense? What I'm looking for is like, which way did they do? Sometimes they could do more than one. They could do 2 bad things, you know. So let's try this guy right here. This is what it would look like if they turned it around. Sorry, everything's backwards, but when I flip it over, it's like it should start at 0 and go up to 1,000, and you see the data better that way. But it's kind of weird because all the words are backwards. So how about this? Bad graph. Did they omit the baseline? What do you think? Did they start down here at 0? So that's okay. It's not this one. Did they manipulate the y-axis? That means, did they waste a lot of space with the y-axis? Totally wasted a lot of space. You can't even read this, sorry, but this is about how many wins the Arkansas team has had from 2000 to 2016. And back in these days, before the college football playoffs, this was when you only played a max like 13 in the season kind of stuff. Now you can play up to 16. But it's like, if you can only play 13 games in a season, why the heck are we going up to 100? So this one is reason number 2. And here's what it should look like if you make a good graph. It would look like this. It's like there's no reason to go to 100, go up to 13, and now you can see, okay, the Arkansas had some up years and some bad years, and et cetera. It shows the data better. And then one last one, baby. Who agreed with the courts? The Democrats, the Republicans, or the independents? This is a bad graph. Discuss why with your group. Which one of those 5 reasons is bad for it? Doesn't it make it look like they wanted the Democrats to say, oh, the Democrats agree with the court way more than the Republicans and the independents? Cut the bottom of the graph off. They omitted baseline. This is what the real graph should look like. So it should look more like that. Yes, the Democrats did agree with the court more, but not nearly as drastically as the first graph made it look. Cool. I have one more that's not on the sheet just because it was on my social media feed the other day, and I was like, hey, I'm going to snip this out. Even if you don't know anything about the NFL, because where you live, you probably should be like, hey, this isn't right. Here's a picture I saw on my social media. This is taken the other day. Actually, it's in December. But this is the number of playoff wins these teams have had since 2010. And I looked at that and go, no way that's right. How did I know that? Again, I do follow football a little closer than the average person, but still, like, what team is pretty close to around here that has been very successful quite recently? Say the Chiefs. Kansas City Chiefs, do you think they've won some playoff games since 2010? They're not even on this graph, right? It's like, how the hell are the Chiefs not on here? You know why? Because they cherry-picked this data. Here's what it really looks like. If you found all the information, they cut it off. They said, Bills, we put this out on our social media and look at our playoff wins, and it's like, bro, you kind of cut off all these other teams because they cherry-picked that data and said, look at us, we are special. And it's like, it was wrong information, but they cut off a bunch of other valuable information that said, hey, the Chiefs have kind of won 3 Super Bowls, and the Patriots have won 3 Super Bowls, all this crazy stuff there. It's like, they weren't even on the list. Right? So, cool. I'll let you do the homework. It is due at the end of the hour. Let me know if you have any questions.